Welcome to Pathology Central Short Takes, Severe Combined Immunodeficiency, the Navajo Nation, and the Jicarilla Apache. In this video, I'll be addressing the increased incidence of this rare recessive disease in these populations. You'll see reference to this made in a variety of medical texts, such as Robbins' Basic Pathology and Up to Date. The latter is more specific, referring to the particular subtype of severe combined immunodeficiency, which is seen in these populations, and which is referred to as Athabascan SCID, or SCID-A. Athabascan refers to the linguistic group from which the Navajo and the Apache are descended. And in these populations, we have an incidence of about 1 in 2,000 live births, compared to 1 in 72,500 in the general population. Severe combined immunodeficiency is due to a block in T-cell differentiation that variably affects B cells, natural killer cells, and myeloid cells. There are a variety of different etiologies, including defective thymic development, as in DeGeorge syndrome, and defects in nucleotide salvage pathways, cytokine signaling, and VDJ recombination. Depending on the pathway involved, inheritance may be either X-linked or autosomal recessive. And children typically present with failure to thrive and recurrent infections, particularly of the gastrointestinal tract and respiratory system. Without treatment, children typically die before the age of 2 years. In 1980, researchers identified 5 Navajo children with marked T and B lymphopenia. In addition to the typical presentation, they also had unusual oral and genital ulcerations. After doing kindred analysis and getting extensive family histories, the researchers identified that this was a significant contribution to mortality in this population. For example, in 1976, 10% of the deaths in children under 2 years old were due to severe combined immunodeficiency. In this time, due to malnutrition and lack of access to care, unfortunately, death due to infection was not uncommon. And so no one recognized that there might be some sort of inherited disease in play here. Since then, researchers have identified the populations that were specifically involved, including the Navajo and Jicarilla Apache, as well as the Dogrib Indians. And evaluation has shown that the defect is due to a truncation of the DCL-RE1C gene, which encodes the Artemis protein. And Artemis is involved in VDJ recombination and DNA repair. Now, in order to not use the name of this linguistic group, Athabascan, which can be seen as somewhat pejorative or negative to have that associated with a disease, it's been recommended that because it is Artemis deficient, that this could be referred to as Artemis deficient severe combined immunodeficiency. Now, don't panic when you see this. I know I do because I'm not a hematopathologist, but I just want to show you where Artemis comes into play. Here we have the hematopoietic stem cell that goes down to the common lymphoid progenitor. We have our pro-T and pro-B cells, and before they can advance to pre-T and pre-B, we need Artemis to play its role in VDJ recombination. For a review of VDJ recombination, I highly recommend Dr. Abbas's book, Cellular and Molecular Immunology, which is where this image comes from. So we have blockage in SCID-A, that prevents the development of pre-T and pre-B cells, which is why these children are so compromised. So why is there this high incidence? Well, what we have here appears to be due to a population bottleneck. We don't know exactly how many indigenous people were in North America prior to the arrival of the Europeans, but it's been estimated to be about 6 million. A census was not done of the various tribes. We do know that from 1864 to 68, about 8,000 Navajo were interned at a place called Bosque Redondo, Fort Sumner, or in the Navajo language, Hoeldi, which means place of suffering and fear. And they arrived there after the long walk in which they were basically herded to this particular place, and many died on the long walk. Of the 8,000 or so who survived, another 2,000 died at the reservation due to dysentery, exposure, and starvation. But from the 6,000, the population expanded to more than 330,000 in the 2010 census. The Jicarilla Apache were also interned at the place of suffering and fear. but we don't have an accurate count until 1914 to 17, where about 600 Jicarilla Apache were known to be extant. And in the 2010 census, there were 3,254. The Jicarilla Apache are very close to the Navajo Nation, and there is intermarriage, although both of these populations have been very careful through marrying outside of their clan to maintain population diversity. So what we have here, if you go from about 6,000 to 330,000, or from 600 to 3,250, is a population bottleneck. So let me explain briefly the population genetics behind this. So if you have a population here, the different balls each indicate a single gene, and the different colors are different alleles. So the most commonly seen are yellow and blue, and there are scattered red alleles. If you have decimation, or in the case of the Navajo and the Apache, more than decimation, so that you have just a small population that survives, when they then expand, these rare alleles will expand. And since it's a recessive disease, you have an increased risk of passing this on to children. Now, the flip side to this is that you can also get a loss of alleles. And this has been seen as far as HLA variability, which tends to be reduced in several Native American populations. So this accounts for the increased risk of severe combined immunodeficiency in the Navajo and Jicarilla Apache. So how can we use this for good? Basically, in February 2012, newborn screening was made available for severe combined immunodeficiency in all the Navajo Nation maternity hospitals in Arizona and New Mexico. They were very careful with informed consent, and 2/3 of families declined to be tested due to probably mistrust of the government. But through this study, 4 patients were identified with severe combined immunodeficiency, and the diagnosis had been previously unsuspected. In fact, one of the children had been treated with a live vaccine, which caused some illness. But because of this newborn screening, the children were able to receive hematopoietic cell transplants and at an early age. The screening also revealed a 5th individual who had T-cell lymphopenia, which was not related to severe combined immunodeficiency, Artemis type. So having a knowledge of the population genetics and being aware of this can help us to be sure that these children get the appropriate treatment, the hematopoietic stem cell treatment, transplant, so that they will thrive and survive. Here are my references. Please put comments or questions down below, and thank you as always for listening.